The smallest pipe that has a standing wave will look like this. If we draw in the rest of the wave, this is one wavelength. So you can see the pipe is 1/4 of the whole wavelength. Here I've drawn some red lines to help us picture that. So the blue wave, this is one whole wavelength. 1/4 of it is here. 1/4 of it is here. 1/4 of it is here. And inside the pipe, we have 1/4 of the wavelength. The whole thing together makes up one wavelength. So we need to divide the wavelength by 4 to get the length of the pipe. And the wavelength is given 0.6 meters. So our pipe is 0.15 meters in length. The next longer pipe that would give us a standing wave would look something like this. If I complete the last segment, that would give us one wavelength. But our pipe stops here. It's 3/4 of that, right? 1/4 is out here, and then you have another quarter here, and another quarter this segment, and another quarter there. So you can see that the pipe is 3/4 of the whole wavelength. So we have to multiply the wavelength by 3/4 to get the length of the pipe. That's 0.6 times 3 divided by 4 gives us 0.45 meters. The next longer pipe that gives us a standing wave would look like this. And if we trace this wave, we have 1/4 of a wavelength to that point, and another quarter to this point. So that's half of a wavelength. This gets us out to 3/4 of the wavelength. And this is a whole wavelength now, where the highlighted section there is one whole wavelength, but we need a little bit more. We need another 1/4 of a wavelength. So 1 1/4 wavelengths is the length of the pipe. 1 1/4 is the same as 5/4. So 5/4 times the wavelength gives us 0.75 meters for the length of the pipe.